this lesson is on solving systems using the combination method. When we look at this problem, 3x equals 30, we know that it means 3 times x equals 30. So 3 times what number is 30? 10. So x must be 10. What happens if we add equal amounts to both sides of the equation? So what if we add 4 to both sides of the equation? We get 3x plus 4 equals 30 plus 4. Is x still equal to 10? Well, 3 times 10 is 30, plus 4 is 34, and that equals the same thing we get on the right-hand side. So it's okay to add the same thing to both sides of our equation. We can also look at, is it okay to subtract the same thing from both sides of the equation? Well, 3x minus 2, that would be 30 minus 2 equals 30 minus 2. So we get the same thing. As long as we add or subtract the same number to both sides of an equation, we can do that. It's also okay if we say we had 3x plus 10, or 3x equals 10. We know 2 plus 3 is the same as 5. Would it be okay to add on this side, add 2 plus 3 to our x, and on this side add 5? Well, we get 3x plus 5 equals, oh, that was equal to 30 before. Sorry. So this was 30. We're using the same equation as before. 30, so we get 35. Is x still 10 like we said on the previous page? Yeah, because 3 times 10 is 30 plus 5 is 35. So it's okay to add them even if they look different as long as their value is the same. So let's look at these two equations. We can use this when we're solving systems of equations. X plus y equals 12 is our first equation, and 2x minus y equals 3 is our second equation. When we read this, 2x minus y equals 3, that means those two things are equivalent. And what we're going to do is add this to the left side of the equation and add 3 to the right side of our equation. So we get x plus y, that's what the first equation said, and we're going to add 2x minus y. And on the right side of the equation, we're going to add 3 to the 12. So we have 12, and now we're going to add 3. Well, when we simplify this and combine like terms, we get x plus 2x is 3x, and y minus y is 0, equals 15. Well, why did those y's cancel out? They canceled out because they were opposites. So when we added them, we got 0. So the benefit of this method is one of your variables is going to cancel out and put you down to one variable. Like here we ended up with 3x, and then when we divided by 3 on both sides, we got x was 5. Once we know x is 5, we can plug it back into one of our equations. We would say this one looks easier, so plug x. You know x plus y equals 12. Plug in a 5 for x, because that's what we got. Subtract 5, and y equals 7. So your ordered pair is 5, 7. This combination method is taking the left side and adding it to the left side, and the right side and adding it to the right side. It's most beneficial when two of our terms are opposites. Those two are opposites. Let's look at another problem. Here we have 12x plus 3y equals 18 and 5x plus 3y equals 4. If we look at our y's, they're not opposite this time like they were before. So instead of adding to both sides, we're going to subtract. We're going to do the left side minus the left side and the right side minus the right side. So 12x plus 3y minus, and since we're subtracting a binomial, let's put that in parentheses, 5x plus 3y. And on the right-hand side, we have 18 minus 4. So 18 minus 4, that gives us 14. Over here on the left side, we'll need to distribute our minus sign. So we get 12x plus 3y minus 5x and minus 3y. And when we combine like terms, our y's cancel out, and 12x minus 5x is 7x equals 14. We divide by 7, we get x equals 2. Once we know x, we can plug it back into either of these equations. I'm going to take the second one this time. So 5x plus 3y equals 4. 5x plus 3y equals 4. I'm going to plug in a 2 for x, so 5 times 2 plus 3y equals 4. 10 plus 3y equals 4. Subtract our 10 so we can get y by itself. 3y equals negative 6. We can divide by 3. And we get y equals negative 2. So our ordered pair is a positive 2 for x and a negative 2 for y. And that's how you do the elimination method, or we call it sometimes the combination method.